Nobody on Earth has measured the speed of light since 1983, and it is not because the equipment failed. Ask why a room full of delegates outside Paris was able to vote on a number about the physical universe and have the universe go along with it. Ask what a Soviet lens designer, arrested for supposedly agreeing in 1909 to spy in a war that had not been invented yet, has to do with any of that, and ask why the whole argument was finally settled by two neutron stars that collided 130 million years ago in a galaxy almost nobody had heard of. Those three things are the same story. They have one answer between them, and the answer is that the most famous constant in science has been carrying the wrong name since 1865. Light is not the thing going that fast. Light is a passenger. Get comfortable and stay to the end, because by the time we finish tonight, you are going to understand why there is no such thing as now, and why that falls directly out of a number a committee wrote into the definition of the meter. If you want these episodes without ads, that is over on our Patreon, Meridian Labs, which this channel is part of along with a handful of others like it. Ad-free episodes from every channel in the group, early access before anything goes public, and the full research archive behind each one. Subscribe or join if you have not. Let's start where it started. On the 21st of October, 1983, in a conference hall in the town of Sèvres just outside Paris, a room full of delegates from around 40 countries voted to stop measuring the speed of light. Not pause it. Not defer it pending better equipment. Stop it. Permanently, and since that afternoon there has not been a single legitimate measurement of the speed of light performed anywhere on this planet, and there never will be again. That is neither a metaphor nor an exaggeration. It describes a procedural fact about how physics works now. The number is 299,792,458 meters per second. Exactly, not approximately. Not to within some tolerance. Exactly, with no error bars, because the 17th General Conference on Weights and Measures wrote it into the definition of the meter. A meter is now defined as the distance light travels in 1,299,792,458th of a second. Which means, if you build the most precise interferometer in human history, cool it to a fraction above absolute zero, isolate it from every vibration, and measure the speed of light and you get a different number, you have not discovered anything about light. You have discovered that your meter stick is the wrong length. Think about what that actually requires. For a committee of human beings to be able to legislate a number about the physical universe and have it stick, the number cannot be a fact about the physical universe in the way you assume it is. You cannot vote on the mass of the proton. You cannot legislate the charge of the electron. Those things are out there, stubborn, indifferent, and they will make a fool of any committee that tries to fix them by decree. But they fixed the speed of light. And it worked. And nothing broke. The reason it worked, the reason a room of delegates could simply write down a number and have the universe comply, is the thing this video is about. The speed of light is not a fact about light. It has never been a fact about light. Light is a passenger. It is going that fast because it has no choice, and the thing that gives it no choice is the geometry of space and time itself, which would have exactly that same speed built into it if light had never existed at all, if photons had a mass, if the entire electromagnetic field had simply failed to show up when the universe was being assembled. Physicists know this. Nobody in the field disputes it, and nobody regards it as fringe. It sits in the textbooks if you look at the right pages, and it has been derivable from first principles since 1910, and almost none of them will say it plainly in public, because saying it plainly requires admitting that the single most famous constant in science has been carrying the wrong name for 160 years, and that the name has been quietly deforming how 3 generations of people understand what space and time actually are. I want to be careful here, because there is a version of this claim that is conspiratorial nonsense, and I have no interest in that version. Nobody is hiding anything. There is no suppressed paper. What there is instead is something more ordinary, and I think more corrosive. There is a naming convention that made sense in 1865 that stopped making sense around 1908, and that nobody has been willing to spend the institutional capital to change. And because the name never changed, the intuition never changed. You still picture a beam, you still picture something racing, and the actual answer, the one that falls out of the mathematics when you strip the light out of it entirely, is that there is no racing at all. There is a conversion factor. There is an exchange rate between 1 second and 1 metre, and the universe applies it whether or not anything is moving. That exchange rate is the reason you cannot outrun a message. It is the reason cause has to come before effect. And by the end of this, if I do my job properly, it is going to be the reason you have to seriously consider that tomorrow already exists. That it is sitting out there in the same sense that Tuesday last week is sitting out there, and that your sense of moving forward through time is a feature of your nervous system rather than a feature of the world. Hold that. We will get to it. It is worse than it sounds. Start with the man who spent his life on the number that got voted out of existence. Albert Abraham Michelson was born in 1852 in Strzelno, in what was then Prussia, and he was brought to America as a small child by parents fleeing after the failed revolutions of 1848. He grew up in mining camps in California and Nevada, the son of a dry goods merchant selling supplies to prospectors. And he talked his way into the United States Naval Academy at Annapolis by petitioning President Grant directly after failing to place in the competitive examination. He was, by every account, difficult, obsessive, and impossible to work with for long stretches, and from roughly 1878 until the day he died, he measured the speed of light. Not as one project among several, as the project. He measured it as a 26-year-old naval instructor with borrowed equipment. He measured it in 1879 with a rotating mirror and got 299,940 kilometers per second, a figure that stood as the best in the world for a generation. He measured it in 1926 by bouncing a beam from Mount Wilson to a mirror on Mount San Antonio, 22 miles away across the Los Angeles basin, using a rotating mirror with 8 faces, then 12, then 16, and he got 299,796 kilometers per second. The commonly quoted uncertainty on that result is about 4 kilometers per second, although you will also find 1 kilometer per second cited for the weighted mean of his runs, and the discrepancy between those two figures is itself a small lesson in how precision gets reported. And then he built the last one. A tube, a mile long, sealed and evacuated so that the light would not have to pass through air. On the Irvine Ranch in Orange County, California, he was in his late 70s. He had already won the Nobel Prize, in 1907, the first American to win it in the sciences. He did not need this. He died in May of 1931, in the middle of the measurement series. The work was finished by his collaborators and published under his name after his death. The apparatus itself was later wrecked by the Long Beach earthquake. Here is the part I keep turning over. Michelson gave something like 50 years of a human life to pinning down a number, refining it decimal place by decimal place. And 52 years after he died, a committee looked at that number and decided it did not need to be measured anymore. Not because the measurements were bad, because they had become the wrong kind of activity. The thing he was chasing turned out not to be out there in the world waiting to be found. It was a unit conversion, and you do not measure a unit conversion, you choose one. But that is not the cruel part of Michelson's story, and I am not going to leave it there, because the cruel part is that he had already run the experiment that made his life's work meaningless, and he spent the rest of his career refusing to accept what it meant. We will come back to that. For now, sit with the shape of the problem. There is a number. Everything in physics is nailed to it. It appears in the equation for the energy in a lump of matter, it appears in the field equations of general relativity, it sets the maximum rate at which any influence can propagate anywhere in the universe, and it turns up in the mathematics of situations that contain no light whatsoever. And when you ask the simple question, the one a bright child would ask, which is what exactly is going that fast, the honest answer is not light. The honest answer is that we do not entirely know. We know what it is the speed of. We do not know why the universe has one. That is the question underneath everything that follows, and I want to be upfront that it does not get answered. Not by me, not by anyone. Every section of this is a different route to it, and every route dead ends somewhere interesting. The first route runs backwards, through everyone who ever tried to catch it. For most of recorded history, the consensus position was that light does not have a speed at all. Aristotle argued that light is not a movement but a presence, a state that space is either in or not in. And if that sounds primitive to you, it is worth remembering that it is also more or less what you experience. Flip a switch. The room is lit. There is no interval. Descartes held the same view as late as the 1630s, and he held it strongly enough to stake a public argument on it, writing that if light took any measurable time to travel then during a lunar eclipse the sun, the Earth and the Moon would not appear to line up properly, and since they do line up properly, light must be instantaneous. It was a genuinely good argument. It was also wrong for a reason nobody could see at the time, which is that the effect he was looking for is there, it is just far too small for a 17th century observer to catch. The man who caught it was a Dane named Ole Rømer, and he was not looking for the speed of light, he was looking at Jupiter. Rømer arrived at the Paris Observatory in 1672 as an assistant to Giovanni Domenico Cassini, the most influential astronomer in Europe and the director of the observatory. The task assigned to him was practical and boring. Jupiter has a moon, Io, which orbits the planet in about 42.5 hours, and once per orbit it disappears into Jupiter's shadow and then reappears. Those eclipses are visible from anywhere on Earth with a decent telescope, which makes them an astronomical clock. If you know exactly when an eclipse of Io is supposed to happen, and you observe when it actually happens where you are standing, you can work out your longitude. That was the great practical problem of the age. Ships were being lost because nobody could reliably determine east and west position at sea. Fortunes were on offer. The trouble was that Io refused to keep time. The eclipses ran early during part of the year and late during another part, and the drift was substantial, minutes at a time accumulating over months. Cassini himself had noticed the irregularity and had even floated the possibility that light takes time to travel before backing away from it. Rømer did not back away. In August of 1676 he made a prediction. The eclipse of Io due on the 9th of November, he said, would occur about 10 minutes later than the tables indicated. He would not say why. He put the prediction on the record and left it there. On the 9th of November the eclipse occurred late, at the time he had said. 2 weeks later, on the 21st of November, 1676, he presented his explanation to the Royal Academy of Sciences in Paris. Io was perfectly punctual. What was changing was the distance the light had to cross to reach us, because Earth was moving toward Jupiter for half the year and away from it for the other half. And light, he said, takes about 22 minutes to cross the full diameter of the Earth's orbit. Notice that he did not give a speed, he gave a duration. He had no reliable figure for the size of Earth's orbit, so he could not convert. That conversion was done a little later, most famously by Christian Huygens in his treatise on light, using Cassini's estimate of the orbital diameter, which was too small by around 7%. I should flag the number honestly, because this audience will check it. 22 minutes is wrong. The actual time for light to cross the diameter of Earth's orbit is closer to 16.5 or 17 minutes. Rømer's figure implies a speed of roughly 226,000 kilometers per second, about 24% below the true value. The most commonly cited version of the story gives you the 22 minutes as Rømer's own claim and the 16.7 as the modern value, and the gap between them is not sloppiness on his part so much as the compounding of two independent errors, one in his timing analysis and one in Cassini's orbital geometry. But being wrong by a quarter is not the point. Being finite at all is the point. Rømer had shown that light takes time, that there is a delay between an event happening and you learning that it happened, that when you look at anything, you are looking at the past. Cassini rejected it, publicly and persistently. He preferred an explanation involving irregularities in Io's own orbit, and the Paris establishment largely followed him. And Rømer's results sat in dispute for the better part of 50 years. It was not fully vindicated until James Bradley, working at Kew and then Oxford in the 1720s, found a completely independent route to the same conclusion. Bradley was trying to detect stellar parallax, the tiny apparent shift in a star's position caused by the Earth moving from one side of its orbit to the other. He picked the star Gamma Draconis because it passes almost directly overhead in London, which minimises atmospheric distortion. He found a shift. But it was in the wrong direction and at the wrong time of year to be parallax. What he had found was aberration. Because the Earth is moving and light has a finite speed, you have to tilt your telescope very slightly into the direction of travel, the same way you tilt an umbrella forward when you walk through vertical rain. From the size of that tilt, Bradley derived a speed for light of about 301,000 kilometers per second, which is within 1% of the modern value, and he communicated it to the Royal Society in 1729. 53 years after Rømer, the finite speed of light was finally accepted. Rømer himself had gone home to Denmark long before, where he became, of all things, the Chief of Police of Copenhagen. He also served as the head of the State Fire Service, which carries a particular sting, because most of his astronomical papers and observation records were destroyed in the Copenhagen fire of 1728. Therefore, the number had to be found again, on the ground this time, without waiting for planets. Hippolyte Fizeau did it in 1849 with a toothed wheel. The apparatus sat in Sèvres, on the western edge of Paris, and fired a beam at a mirror on Montmartre, 8,633 meters away. Between the source and the distance, a wheel with 720 teeth. Spin the wheel and the beam is chopped into pulses. Spin it fast enough and a pulse that got out through one gap comes back to find a tooth in the way. Spin it faster still and the returning pulse slips through the next gap. The first blackout came at 12.6 rotations per second. The light reappeared at 25.2. From that, and the distance and the tooth count, Fizeau calculated 313,000 kilometers per second. About 5% too high, which for the first terrestrial measurement of the speed of light using a wheel and a candle is astonishing. And then Léon Foucault did something more important than getting a better number, although he also got a better number. Foucault was a strange figure in French science. He had trained as a physician and abandoned it because he could not tolerate the sight of blood. He was largely self-taught in physics, distrusted by the academic establishment for having no formal credentials, and he is remembered today mainly for a pendulum. In 1850, he replaced Fizeau's wheel with a rotating mirror, which allowed him to run the whole experiment over a much shorter path, a few meters instead of several kilometers. And that meant he could put things in the path. On the 27th of April, 1850, Foucault sent light through a tube of water and compared its speed to light travelling through air. Understand what was at stake in that measurement. There were two competing theories of light, and they made opposite predictions about exactly this. Newton's corpuscular theory, which had dominated for a century and a half on the strength of Newton's name, required that light speed up in a dense medium. The wave theory required that it slow down. Every other piece of evidence had been argued back and forth for decades. This was clean. Light in water was slower. Newton was wrong. The wave theory was correct, and the corpuscular picture, which had survived largely because of the authority of the man who proposed it, collapsed in a single afternoon in a Paris laboratory. In 1862, Foucault refined his rotating mirror method and produced a value of 298,000 kilometers per second, within about 0.6% of what we now use. He died 6 years later, in 1868, at 48, of a rapidly progressing illness that was almost certainly multiple sclerosis. He lost the use of his hands first, which for an experimentalist who ground his own optics is a particular kind of cruelty, and then his speech. Every single one of these people believed they were measuring a property of light. Rømer thought he was timing a beam. Fizeau thought he was clocking a pulse through a gap in a wheel. Foucault thought he had proved something about the nature of luminous matter, and in a sense he had. They were all working on the assumption that light is a thing that moves, that its speed belongs to it the way a horse's speed belongs to the horse, and that if you could somehow remove light from the universe, the number would go with it. But within 20 years of Foucault's death, a Scotsman working on electricity and magnetism was going to produce that same number from an equation with no light in it. And the way physics reacted to that is the reason you were never told any of this. In 1856, two German physicists named Wilhelm Weber and Rudolf Kohlrausch performed an experiment that had nothing to do with light and no obvious connection to it. The problem they were working on was a bookkeeping problem. In the middle of the 19th century there were two entirely separate ways to define a unit of electric charge. You could define it electrostatically, by how hard two charges push each other apart, or you could define it electromagnetically, by how hard two currents pull on each other. Both definitions worked. Both were in use. And they gave different numbers for the same charge, which meant there had to be a conversion factor between them, and nobody knew what it was. Weber and Kohlrausch measured it. They charged a Leyden jar, which is essentially a glass jar lined inside and out with metal foil, the earliest capacitor, and they measured its charge electrostatically. Then they discharged it through a galvanometer and measured the same charge electromagnetically. The ratio between the two numbers came out at 3.10, 7 times 10 to the 8th, in units of meters per second. Meters per second. A velocity produced by an experiment involving no motion, no light, and no propagation of anything. Just a jar, a foil lining, and two ways of counting the same charge. They noticed it was suspiciously close to Fizeau's speed of light. They wrote it down. And then, as far as anyone can tell, they let it go, because there was no framework in which that coincidence could mean anything. James Clerk Maxwell provided the framework. Between 1861 and 1865, working first on a mechanical model of the electromagnetic field that he himself did not believe in literally, and then on the abstract equations that survived when the model was thrown away. Maxwell showed that a changing electric field produces a magnetic field, and a changing magnetic field produces an electric field, and that this mutual production can sustain itself as a wave travelling through empty space. And when he solved for the speed of that wave, he got 1 divided by the square root of 2 constants, the permittivity of free space and the permeability of free space, both of which had been measured in laboratories using nothing but wires, magnets and static charge. The number that came out was the speed of light. Maxwell knew exactly what he had. In the 1865 paper, A Dynamical Theory of the Electromagnetic Field, published in the Philosophical Transactions of the Royal Society, he wrote that the agreement of the results seems to show that light and magnetism are affections of the same substance, and that light is an electromagnetic disturbance propagated through the field according to electromagnetic laws. It is one of the great sentences in the history of science, and it is entirely correct. It also did the damage, because the way that discovery was absorbed, and the way it has been taught ever since, is that light is electromagnetic, and therefore the speed of light is an electromagnetic quantity. It comes out of the electromagnetic constants. It belongs to the field. Take away electromagnetism, and you take away the number. That is the story. That is what the equation appears to say. 1 divided by the square root of the permittivity and the permeability, and both of those are properties of the electromagnetic vacuum, so the speed is a property of the electromagnetic vacuum. And for 160 years that framing has held, in classrooms, in textbooks, in the popular imagination, and in the name of the constant itself. Here is what changed, and almost nobody outside metrology noticed. Since the 20th of May, 2019, when the redefinition of the base units of the international system came into force, the permeability of free space is no longer an exactly defined constant. It used to be exactly 4 pi times 10 to the -7th by definition, fixed as part of the old definition of the ampere. Now it is a measured quantity, with an experimental uncertainty of about 1.6 parts in 10 billion, determined through its relationship to the fine structure constant, the electron charge, the reduced Planck constant, and the speed of light. The permittivity of free space is likewise now derived, because it equals 1 over the permeability times the speed of light squared. Read the direction of that dependency again. The speed of light is fixed by definition. The electromagnetic constants are now measured, and they are measured in a way that is pinned to the speed of light. Maxwell's equation still holds exactly. 1 over the square root of the permittivity times the permeability still equals the speed of light, to arbitrary precision, because the uncertainties in the 2 constants are equal and opposite and cancel. But the causal story has inverted. It is no longer the case that we determine the speed of light from the properties of the electromagnetic field. We determine the properties of the electromagnetic field from the speed of light. The constant that was supposed to be a consequence of electromagnetism is now the thing electromagnetism is calibrated against. Nobody announced that. There was no press release. It was a technical consequence of a metrology reform that most physicists experienced as a change in how the kilogram is defined. And the implication for how we should think about what the speed of light actually is went almost entirely undiscussed outside of standards bodies. I have read a reasonable amount of the popular material published around the 2019 redefinition, and I cannot find anyone making this point in plain language for a general audience. It is not hidden. It is just not interesting to the people who understand it, because they already knew. That is the shape of this whole story, by the way. Not suppression. Something more like a shrug. Which brings me to the name. You have probably heard that the letter C, the symbol for the speed of light, stands for celeritas, the Latin word for swiftness. It is a satisfying explanation. It is repeated in textbooks, in documentaries, on physics websites, and it has the pleasing quality of making the symbol seem inevitable. It is almost certainly not true, and the reason it is not true tells you something. The trail of that claim runs back to a science essay by Isaac Asimov, published in November 1959 in the Magazine of Fantasy and Science Fiction, titled C for Celeritas. Asimov was a superb explainer and a genuinely learned man, and he was also, in this instance, offering a plausible reconstruction rather than a documented history. It caught on because it was tidy. What the actual record shows, as traced by the physicist Kenneth Mendelssohn in a paper in the American Journal of Physics in 2006, and independently in the well-known Relativity FAQ maintained through the University of California at Riverside, is messier and much more interesting. The first person to use the letter C in this context was Wilhelm Weber, the same Weber, who used it in the 1840s for the constant in his electrodynamic force law. It was not the speed of light, it was probably just C for constant. Through most of the 19th century, the dominant symbol for the speed of light was capital V. Maxwell used V. Einstein used V in the 1905 paper. The person who appears to have first used C specifically for the velocity of electromagnetic waves is Paul Drude in 1894, and it spread from there through Lorentz and Planck. Einstein himself switched from V to C around 1907. The symbol for the speed of light, then, originated as a symbol for an electrodynamic constant that had nothing to do with light, was adopted for the speed of electromagnetic waves by a German optics theorist in the 1890s, and acquired a Latin etymology retroactively from a science fiction magazine in 1959. The name is a fossil, and the thing about fossils is that people mistake them for the animal. But none of this is yet an argument. Everything so far is history and bookkeeping. You could accept every word of it and still say, reasonably, that light travels at that speed, that this was discovered rather than decreed, that the accounting changes in 2019 are administrative housekeeping, and that calling it the speed of light is a harmless convention. Therefore, the argument has to come from somewhere else, and it does. It comes from a 1905 paper that everyone has heard of, and a 1908 lecture that almost nobody has read, and it turns on the fact that Einstein put light into the foundations of relativity for reasons that were historical rather than logical, and that this was demonstrated within 5 years of him doing it by a man whose name has been almost entirely erased. I promised I would come back to Michelson, and this is where he returns, because in 1887 he ran the experiment that broke physics, and then spent the rest of his life quietly hoping it had not. The logic behind it was simple and, at the time, unanswerable. If light is a wave, it has to be a wave in something. Sound waves need air, water waves need water, light waves therefore need a medium, and that medium was called the luminiferous ether, and it had to fill all of space, including the space between the stars, because starlight gets here. If the ether exists, and the Earth is moving through it at around 30 kilometers per second in its orbit, then there is an ether wind blowing through the laboratory, and light travelling with that wind should move at a different speed relative to the apparatus than light travelling across it. The difference would be tiny, a second-order effect, proportional to the square of the ratio of Earth's speed to light speed, but Michelson had invented an instrument sensitive enough to catch it. The interferometer splits a beam in two, sends the halves down perpendicular arms, bounces them off mirrors and recombines them. If one arm's beam takes even fractionally longer, the recombined light produces a shifted pattern of interference fringes. In the version he and Edward Morley built at what is now Case Western Reserve University in Cleveland, the whole apparatus floated on a bed of liquid mercury, so it could be rotated smoothly through every orientation without vibration, and the light path was folded with multiple mirrors to lengthen it to about 11 meters. The expected fringe shift was around 4/10 of a fringe. They rotated it. They rotated it at noon and at 6 in the evening in July of 1887 over multiple days. And in the paper, published in the American Journal of Science that November, they reported that the observed displacement was certainly less than 1/20th of the expected value and probably less than 1/40th, which puts the effect at under 1/100th of a fringe. They concluded that the relative motion of the Earth and the ether is probably less than 1/6 of the Earth's orbital velocity, and certainly less than 1/4. I should flag a figure here because it circulates a lot. You will sometimes see a residual ether drift of around 8 kilometers per second quoted from this experiment. That number does not come from the 1887 paper. It comes from Dayton Miller's later reanalyses and repetitions in the 1920s, which were examined in detail by Robert Shankland and colleagues in 1955 and attributed to temperature gradients in Miller's apparatus. The 1887 result is a null result, and its own authors described it as 1. The most sensitive optical experiment ever performed had gone looking for the medium that light waves through and found nothing. Not a small effect. Not an ambiguous effect. Nothing. Michelson considered this the great failure of his career. He described the experiment's result as disappointing in his own writing about it, and he continued for decades afterwards to look for ways to save some version of the ether, remaining attached to the idea long after most of the field had moved on. There is something almost unbearable about it. He built the instrument that killed the ether, he understood better than anyone alive what the instrument was capable of, and the conclusion the instrument forced was one he never wanted. But the null result on its own does not get you to relativity. Plenty of people tried to patch the ether instead, and one of those patches was very nearly correct. George Fitzgerald in 1889 and Hendrik Lorentz independently in 1892 proposed that objects moving through the ether physically contract along their direction of motion by exactly the amount needed to hide the effect. Lorentz went further and worked out the full set of transformation equations, the ones that now carry his name, complete with what he called local time, a mathematical bookkeeping device he introduced to make the equations work, and did not believe corresponded to anything real. Lorentz had the mathematics of special relativity in hand before Einstein, and did not know what he was holding. He thought he was describing how the ether deforms matter. He was describing the shape of spacetime. Therefore, what Einstein contributed in 1905 was not the equations. It was the willingness to say that the equations were not a patch. The paper is called On the Electrodynamics of Moving Bodies. It appeared in Annalen der Physik in September of 1905, and it opens not with an experiment, but with an aesthetic complaint. Einstein points out that when a magnet moves near a conductor, the standard theory tells one story, and when the conductor moves near the magnet, the standard theory tells a completely different story involving different mechanisms, and yet the observable result is identical in both cases. That asymmetry bothered him. He calls it, in the opening lines, an asymmetry that does not appear to be inherent in the phenomena. He then does the thing that makes him Einstein. He proposes two postulates and refuses to add a third. First, the laws of physics take the same form in all inertial frames. Second, light propagates in empty space at a definite velocity c, which is independent of the motion of the emitting body. And there it is, light in the foundations, in the second postulate, load-bearing, at the base of the entire structure. Everything that has confused people about relativity for 120 years is downstream of that choice. Because if the constancy of the speed of light is an axiom, then the speed of light is fundamental, and light is doing something special. and the whole edifice of time dilation and length contraction and mass energy equivalence appears to rest on a fact about photons. It does not. And Einstein knew it did not, in the sense that he understood he was choosing a convenient empirical anchor rather than a metaphysical foundation. But he was writing in 1905 in a patent office in Bern for an audience of electrodynamicists, and the constancy of the speed of light was the one experimental fact he could point at that everyone would accept. It was the strongest available handle, and he grabbed it. The correction came 3 years later from his former mathematics professor, who had once described Einstein as a lazy dog. Hermann Minkowski was born in 1864 in what was then the Russian Empire, in a village near Kaunas in modern Lithuania, to a family of German Jewish merchants who moved to Königsberg when he was 8. He was a prodigy of a fairly extreme kind. At 18, he shared the grand prize of the Paris Academy of Sciences for work on the representation of numbers as sums of 5 squares, sharing it with Henry Smith, who had died before the prize was announced. He taught at Zurich, where Einstein was one of his students and, by his own later account, not an impressive one. In 1902 he went to Göttingen, at the time the mathematical centre of the world. And on the 21st of September, 1908, at the 80th Assembly of German Natural Scientists and Physicians in Cologne, Minkowski delivered a lecture called Raum und Zeit, Space and Time. It begins with one of the most quoted sentences in physics. "The views of space and time which I wish to lay before you," he said, "have sprung from the soil of experimental physics, and therein lies their strength. They are radical. Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." What Minkowski had realized is that Einstein's 2 postulates, taken seriously, are not statements about light or about measuring rods. They are statements about geometry. If you stop thinking of space as a 3-dimensional stage on which events happen over time, and instead treat time as a 4th dimension of a single 4-dimensional structure, then everything in relativity becomes a statement about the shape of that structure. Time dilation is not a mysterious effect on clocks. It is what you get when you project a 4-dimensional object onto different 3-dimensional slices, the same way a stick looks shorter when you look at its shadow from a different angle. And in that 4-dimensional geometry, there is a quantity that all observers agree on, no matter how fast they are moving relative to each other. It is called the spacetime interval, and its formula is the time between 2 events, multiplied by c squared minus the distance between them squared. Look at what c is doing in that expression. The first term is a duration. The second term is a length. You cannot subtract seconds from meters. The expression is meaningless unless something converts one into the other. And c is that something. It is the exchange rate. Multiply a time by c and you get a distance. That is its entire job in the fundamental equation of spacetime geometry. Minkowski did not live to see what he had done. On the 12th of January, 1909, less than 4 months after the Cologne lecture, he collapsed with severe abdominal pain. It was appendicitis. His appendix ruptured. He died on the same day at the age of 44. He had, at that point, published the Cologne lecture but not developed the framework further. He never saw general relativity, which Einstein built directly on Minkowski's geometry and could not have built without it. He never saw his 4-dimensional formalism become the standard language of theoretical physics. He got the idea, said it out loud once, in one lecture, in Cologne, and then his body killed him inside a season. There is a detail from that lecture that I want to plant here, and I am telling you now that we are going to come back to it, because it does not look like much on first reading, and it is the most disturbing sentence in this entire story. In the Minkowski picture, the entire history of the universe is laid out as a single fixed geometric object, not a thing that develops, a thing that is. What we experience as the passage of time is our own world line threading through a structure that, from the outside, is not going anywhere. Minkowski did not emphasize that. He mentioned the geometry and moved on to the mathematics of the transformations, but it is right there in the first 4 months of the theory's existence, and it has never gone away. And by the end of this, it is going to be the only thing left standing. For now, the immediate problem. Minkowski had shown that relativity is geometry, but the light postulate was still sitting at the base of it, still apparently required, still telling everyone that a fact about photons is what holds the structure up. Somebody had to show that it was not required at all. Somebody did, in 1910. And what happened to him is the ugliest thing in this story. Vladimir Sergeyevich Ignatowsky was born in March of 1875 in Tbilisi, in Georgia, then part of the Russian Empire. He studied in Germany, at Gießen, and he worked in optics, on lens design and instrument theory, which is a fairly unglamorous corner of the field. He was not a member of the Berlin or Göttingen circles. He was not anybody's student in the way that mattered for a career. In 1910 he published a paper in the Archiv der Mathematik und Physik, followed by a companion paper in the same journal in 1911, in which he asked a question that apparently nobody had thought to ask. What happens if you try to derive the transformation between moving reference frames using only the principle of relativity and nothing else? Not the speed of light, not electromagnetism, no experiment about beams, just the requirement that the laws of physics are the same for everybody, plus a handful of assumptions so basic that you would not even notice they were assumptions. Here is what he used. First, space is homogeneous, which means an experiment gives the same result in Berlin as in Tbilisi. Second, space is isotropic, which means it gives the same result whether you face north or east. Third, time is homogeneous, which means it gives the same result on Tuesday as on Friday. Fourth, the transformation between frames has to form a group, meaning that if you transform from frame A to frame B, and then from B to C, the combined operation is itself a legitimate transformation from A to C. Fifth, a form of reciprocity, meaning that if I see you moving away from me at a certain speed, you see me moving away from you at that same speed. That is the whole input. Those are statements about symmetry. There is not a photon anywhere in the list. And out of that, purely from the algebra, Ignatowsky derived the Lorentz transformation. The full thing. Time dilation, length contraction, the velocity addition rule, the lot, with one feature that is the entire point of this video. The transformation that falls out contains a constant. A speed. It emerges from the mathematics as an unavoidable structural feature, a maximum velocity built into the relationship between space and time, and the derivation cannot tell you what its numerical value is. The algebra says there must be an invariant speed. It has no opinion whatsoever about how fast that speed is, and it certainly has no opinion about what, if anything, travels at it. Read that again, because it is the load-bearing sentence in everything that follows. The invariant speed is not put into relativity from experiment. It falls out of the requirement that space is the same everywhere and in every direction, and that physics does not care who is doing the measuring. The universe has a speed limit because of its symmetry, not because of its contents. The value has to be supplied from outside, by measurement. And here is where the last piece drops into place. If that constant were infinite, you would recover Galilean physics, the ordinary common sense world where velocities just add and simultaneity is universal. The mathematics permits that, It is a perfectly consistent universe. It just is not this one. In our universe, the constant is finite, and it happens to be 299,792,458 meters per second, and light happens to travel at exactly that speed, and the second of those two facts is a coincidence of a very particular and specific kind that we will get to. Ignatowsky was not alone for long. Philipp Frank and Hermann Roth published a more rigorous version in Annalen der Physik in 1911, and then, remarkably, the whole thing went quiet for over half a century. It resurfaced in the 1970s. John Mark Levy-Leblond published a paper in the American Journal of Physics in 1976 with the deliberately deadpan title One More Derivation of the Lorentz Transformation, Volume 44, pages 271 to 277, laying out the argument cleanly for a teaching audience. David Mermin, at Cornell, published Relativity Without Light in the same journal in 1984, Volume 52, pages 119 to 124. Palash Pal published a version in the European Journal of Physics in 2003 under the title Nothing But Relativity. There are others. Leon Colotis in 1975, Berzi and Guarini in 1969. This is not obscure. These are mainstream journals. The American Journal of Physics is read by physics teachers, which is to say by exactly the people who decide what you get told about relativity. And you were not told. I want to be scrupulous here, because there is a real technical objection and this audience deserves it, rather than a clean story. The derivations are not quite as free as the marketing suggests. Roberto Turretti, among others, has argued that Ignatowsky and his successors smuggle in additional assumptions, most notably the reciprocity condition and the requirement that the transformations be linear, and that these are not as innocent as they look. That is a fair criticism, and the literature has been arguing about the minimal assumption set for 50 years. What nobody disputes is the headline result. You can build special relativity without ever mentioning light, and when you do, an invariant speed appears anyway. The question therefore becomes institutional. If this has been available since 1910 and re-derived every decade or so since 1969, why does every introductory treatment still open with the light postulate? The answer is not sinister, and that is what makes it worse. What it comes down to is pedagogical inertia. The light postulate is easier to teach because it points at something students can imagine. It has a famous experiment attached to it. It fits in a lecture. The symmetry derivation requires more algebra and offers no picture at all, just a structural claim about the shape of a group of transformations. Given a choice between a false intuition that gets students through the exam and a true abstraction that does not, the system chooses the exam every time, and 120 years of that choice has produced a population of intelligent people, including people with physics degrees, who believe at a gut level that light is somehow the boss of the universe, that there is a beam out there setting the pace and everything else is trying to keep up. There is no beam, there is a shape, and light fits inside it. Ignatowsky, meanwhile, went home. He returned to Russia and had a substantial career in optics, working on lens design at the State Optical Institute in Leningrad, publishing on diffraction theory, solid, useful, unglamorous work. And in 1941 or 1942, depending on which account you follow, he was arrested. The charge, as recorded in Alexander Solzhenitsyn's Gulag Archipelago, is one of the more grotesque things I have encountered in the course of researching anything. Ignatowsky was accused of having been recruited by German intelligence in 1909, not for the war that was then happening, not even for the First World War. He was alleged to have been recruited more than 30 years in advance to spy during what the accusation apparently described as the war after next. He was, according to Solzhenitsyn's account, sentenced and shot in Leningrad in 1942. He was formally rehabilitated in 1955, which is the standard Soviet euphemism for an official admission that the state murdered an innocent person. I have to flag the sourcing on this one honestly, because it matters and because the record is genuinely contested. Other sources render the same death as a death during the siege of Leningrad, meaning starvation during the winter of 1941-42 rather than execution. The dates given vary between the 13th and the 30th of January, 1942. Solzhenitsyn is a literary historical source rather than an archival one. What is not in dispute is that he died in Leningrad in 1942, in a city where roughly 800,000 civilians died of starvation, and that the man who first showed that relativity does not need light disappeared into that with essentially no memorial in the physics literature. Look at the pattern that is accumulating. Rømer, rejected by his director and vindicated 53 years later, his records burned. Foucault, sneered at for having no credentials, dead at 48 with his hands gone. Minkowski, dead at 4 months after the lecture that reframed the entire theory. Michelson, the man who ran the experiment that made relativity necessary and who never quite forgave it. And Ignatowsky, dead in a siege or against a wall in 1942. Having published in 1910 the result that would have changed how every physics course on Earth introduces the subject, if anybody had picked it up. That is not a conspiracy. Nobody coordinated it. It is something duller and more permanent, which is that scientific communities have limited attention and they allocate it according to who is already being listened to. And a lens designer in St. Petersburg publishing in a mathematics journal was not on the list. But there is a consequence here that should genuinely stop you, and it is why the Ignatowsky result matters far beyond a story about academic neglect. If relativity does not need light, then relativity does not care whether light exists, which means there is a version of this universe with no electromagnetic field at all, no photons, nothing that glows, total and permanent darkness. And in that universe there is still an invariant speed, still a maximum rate at which any influence can propagate, still time dilation, still length contraction, still the whole structure. The number would be the same number. Nothing about the geometry of space and time depends on there being anything to see. Therefore, the question is no longer why light travels at that speed. The question is why the geometry has a speed in it at all, and what it means that you are built out of a structure with a hard limit on how fast anything inside it can change anything else. And the first serious answer to that involves a phenomenon that has nothing to do with light whatsoever, that was measured for the first time in 2017, and that settled the argument in a way I do not think has been properly communicated to anybody outside the field. Before we get to 2017, you need the rule that determines who is allowed to travel at the invariant speed and who is not, because it is one line of algebra and it explains everything. In relativity, the relationship between a particle's energy, its momentum and its mass is fixed. Energy squared equals momentum times c squared plus mass times c squared, all squared. That is the full expression. The famous version, energy equals mass times c squared, is what you get from it when the momentum is zero, which is to say when the object is sitting still. It is a special case, and it is the special case that got printed on the shirts. Now set the mass to zero. The second term vanishes entirely. Energy equals momentum times c, and if you work out the velocity that this implies, using the standard relationship between energy, momentum and speed, you do not get something close to c. You get exactly c. Not approximately, not in the limit, not as a good approximation for very light particles. Exactly, and it works the other way too. If a particle has any mass at all, however small, it cannot reach c, because the energy required to accelerate it diverges as it approaches, not gets large. Diverges goes to infinity. That is the whole rule. Massless things travel at the invariant speed and have no choice about it. Massive things cannot reach it and have no choice about that either. Nothing in between, no exceptions, no negotiation. Now, why is the photon massless? Because of a symmetry in the equations of electromagnetism, called U1 gauge symmetry, which is unbroken. A mass term for the photon would violate it, and it is not violated, and that is the mechanical reason light travels at c. The photon is not special. It is unemployed. It has nothing to carry, and therefore nothing to slow it down. Which raises an obvious question. How sure are we that the photon is massless? Not perfectly sure, and it is worth understanding what that actually means. You cannot prove a mass is zero. You can only push the upper limit down. The particle data group, which is the reference collaboration that maintains the accepted values for particle properties and publishes the review of particle physics, currently adopts an upper limit on the photon mass of about 10 to the minus 18 electron volts. To make that visceral, the electron, which is the lightest charged particle we know of, has a mass of about 511,000 electron volts. The limit on the photon's mass is therefore smaller than the electron's mass by roughly 24 orders of magnitude. If the electron were the mass of a fully loaded container ship, the upper bound on the photon would be less than 1 bacterium. That adopted limit comes from analysis of the solar wind, work associated with the physicist Dmitry Ryutov, based on how a photon mass would alter the behavior of magnetic fields in the plasma streaming out of the sun. There are much stronger limits in the literature, down around 10 to the minus 27 electron volts, derived from the galactic magnetic field. The particle data group lists those, but does not adopt them, and the reason is worth knowing. In 2007, Eric Adelberger, Gia Diwali and Andrei Gruzanov published a paper in Physical Review Letters, volume 98, titled Photon Mass Bound Destroyed by Vortices, showing that if the photon mass arises through a Higgs-type mechanism rather than being put in by hand, the strongest astronomical bounds collapse, because the field organizes itself into vortex structures that hide the effect. The honest position is that the photon is massless as far as anyone can measure, that the measurement is extraordinarily good, and that the strongest claimed bounds depend on assumptions about physics we have not verified. And here is the part that should reorganize your entire intuition about this. Suppose tomorrow somebody finds it. Suppose a measurement comes in showing the photon has a mass of 10 to the minus 19 electron volts. What breaks? Relativity does not break. The invariant speed does not change. The spacetime interval does not change. Time dilation, length contraction, the causal structure of the universe, the entire apparatus, all of it survives completely untouched. What changes is that light no longer travels at c. It travels at very slightly less than c, always, everywhere, including in perfect vacuum. The speed of light and the invariant speed of spacetime would become two different numbers, and the second one would still be the one that matters. Every equation in relativity would keep the same constant in it. The constant would simply no longer have anything at all to do with photons, and physics would carry on without a hiccup. And we would presumably keep calling it the speed of light out of habit, because we have never been good at renaming things. That is the cleanest way to see the claim. Light does not define the invariant speed. Light qualifies for it. Light is a passenger who happens to meet the boarding requirement, and the requirement is having no mass, which means, if the argument is right, that anything else massless should be sitting in the same seat, travelling at exactly the same speed, for reasons that have no connection to electromagnetism at all. There is one other massless particle in the standard model. The gluon, which carries the strong nuclear force, has zero mass in the theory. But gluons are confined. They never appear as free particles, they exist only inside protons and neutrons and other hadrons, and you cannot time one crossing a distance. That test is not available. Therefore, the only other candidate is gravity itself. And in general relativity, gravitational waves, which are ripples in the geometry of spacetime, are the disturbance of a massless field. They should travel at exactly the invariant speed, and gravity has nothing whatsoever to do with electromagnetism. Different force, different mathematics, different field, no photons involved anywhere. If gravitational waves travel at exactly the speed of light, the only sensible interpretation is that both of them are travelling at the speed of something else. On the 17th of August, 2017, at 12 minutes and 41 seconds past 12, Coordinated Universal Time, the two LIGO detectors in Hanford, Washington and Livingston, Louisiana, together with Virgo in Italy, recorded a gravitational wave signal lasting about 100 seconds. It was the inspiral of two neutron stars in a galaxy called NGC 4993. At a distance of about 40 megaparsecs, which is around 130 million light-years. 1.74 seconds later, give or take 0.05 of a second, the Fermi Gamma Ray Burst Monitor in orbit detected a short gamma-ray burst from the same patch of sky. Integral confirmed it independently. Two signals. Same event. Same source. One made of space-time geometry, one made of light. They had been travelling side by side for 130 million years, which is about 1.1 times 10 to the 16 seconds, and they arrived 1.74 seconds apart. The published constraint from the joint LIGO, Virgo, Fermi and Integral paper in the Astrophysical Journal Letters, Volume 848, Article L13 in 2017, is that the fractional difference between the speed of gravity and the speed of light lies between minus 3 times 10 to the minus 15 and plus 7 times 10 to the minus 16. I want to make that number physical, because a lot of people read past it. A fractional difference of 10 to the minus 15 means that if you raced a gravitational wave against a light beam from here to the moon and back, a distance of about 770,000 kilometers, they would finish within about a millionth of a second of each other. Over 130 million years, they stayed within a couple of seconds. And the couple of seconds is almost certainly not a speed difference at all. It is astrophysics, the delay between the merger itself and the moment the gamma rays actually got launched and escaped the debris. Two entirely different phenomena, governed by entirely different theories, sharing no mathematics and no particles, arriving with a matched speed to 15 decimal places. There is no reading of that result in which the number belongs to light. The gravitational wave was not travelling at the speed of light. Both of them were travelling at the speed of the universe, which is a property of the stage rather than of anything standing on it, and this was confirmed observationally, at a precision most experiments never get near, on a Thursday in August of 2017. And the way it was reported, almost universally, in press releases and in newspapers and on television, was that scientists had confirmed that gravity travels at the speed of light, which is technically true and is exactly the wrong emphasis. It puts light in the subject position again. It frames the result as gravity being measured against light, when what actually happened is that two independent messengers were measured against each other and agreed, and the agreement is only explicable if neither of them owns the number. I have gone looking for public communication that says this plainly, and there is very little of it. The physicists who wrote the paper understood it perfectly well. Sean Carroll has been saying in public talks for years that the speed of light ought to be called the speed of causality. John Byers' long-standing relativity material lays out the reasoning. Matt Strassler has written about it clearly. It is not a secret. It is simply that the correction requires you to unlearn the name, and unlearning the name means admitting that a century of teaching has been pointing at the wrong object, and nobody wants to be the person who says that at a press conference. But there is a second problem with the phrase the speed of light, and it is not philosophical at all. It is that light almost never travels at the speed of light, and once you see how rarely it does, the whole naming convention starts to look absurd. Everything I have said about the invariant speed applies to light in vacuum. Perfect vacuum. Nothing there at all. Light in vacuum is a laboratory idealization. It is not what light usually does. Almost every photon you have ever personally interacted with was travelling slower than c, most of them substantially slower, and there is nothing exotic about the reason. Glass. The refractive index of a material is the ratio between c and the speed at which light propagates through that material. Water has an index of about 1.33, which means light crosses a swimming pool at around 225,000 kilometers per second. Ordinary window glass is about 1.5. Diamond is about 2.42, which puts light inside a diamond at roughly 124,000 kilometers per second, less than half of c. Every photon that has ever entered your eye passed through your cornea, your aqueous humour, your lens and your vitreous body before it reached your retina. Refractive indices in the region of 1.34 to 1.41. You have never in your life seen anything by means of light travelling at the speed of light. The final centimetres of every image you have ever received were delivered at somewhere around 3/4 of the constant. That effect is well understood. It comes from the light interacting with the electrons in the material, being absorbed and re-emitted and interfering with itself, and the underlying photons between interactions are still moving at c. But the propagation of the signal, the thing you would measure with a stopwatch, is slower, and the amount by which it is slower can be pushed to places that stop sounding like physics. In February of 1999, Lene Vestergaard Howe, a Danish physicist working at the Roland Institute in Harvard, published a paper in Nature, volume 397, page 594, titled Light Speed Reduction to 17 metres per second in an ultra-cold atomic gas. 17 metres per second, about 38 miles per hour. A cyclist going downhill. The technique used a Bose-Einstein condensate of sodium atoms, cooled to within billionths of a degree of absolute zero, in a state where the atoms lose their individual identity and behave as a single quantum entity. A coupling laser is used to make the cloud transparent at a very specific frequency, a technique called electromagnetically induced transparency, and in a narrow window around that frequency, the medium becomes so extraordinarily dispersive that the group velocity of a light pulse collapses by a factor of about 20 million. The pulse, which would normally be over a kilometre long, gets compressed to around 43 micrometers. It fits inside the cloud. In 2001, Howe's group went further and stopped light completely, brought a pulse to a halt inside the condensate, held the information in the atomic states, and released it again on demand. The phrase "the speed of light" gets a little strained when you can stop it, keep it in a jar, and let it out later. There is also a stranger result that I want to give you with its controversy attached. In January of 2015, a team from Glasgow and Heriot-Watt, with Daniel Giovannini as first author and Miles Padgett as senior author, published in Science, volume 347, pages 857 to 860, a paper reporting that photons which have been given spatial structure, shaped into Bessel or particular Gaussian modes rather than being sent as a simple plane wave, arrive slightly late even in free space. The lag was tiny, on the order of 10 to 20 wavelengths over a metre of travel, a few micrometers, roughly 1,000th of 1% slower than c. The result is real, and it has been replicated in various forms. What it means is disputed. Euler-Horvath and Balázs-Major, among others, argued in a rebuttal that the photons are still travelling at c, and what is being measured is the projection of that velocity along the axis of propagation, because a structured beam has transverse momentum components and is therefore not travelling in a perfectly straight line down the axis. That is a genuine interpretive disagreement, and I do not think it is settled. But either way, it makes the same point. Getting light to actually travel at the speed of light requires care. And then there is the sun. The energy that reaches you as sunlight was generated by fusion in the core, and it does not simply fly out. The interior of the sun is dense ionized plasma, and a photon produced in the core travels a fraction of a millimeter before it is absorbed, re-emitted in a random direction, absorbed again, re-emitted again, in a random walk that goes on and on. The photon that leaves the surface is not the photon that was created in the core, in the sense that the energy has been repeatedly absorbed and redistributed on the way. What matters is how long the energy takes to get out, and here I have to flag a genuine and rather embarrassing conflict in the literature. The published estimates for how long energy takes to escape the sun range from a few thousand years to around 1 million years. You will find 4,000, 10,000, 17,000, 40,000, 100,000, and 170,000 years all cited in reputable sources. The spread comes from different assumptions about the mean free path of a photon and different models of the interior density profile, and there is no consensus figure I would be willing to hand you as the answer. The direct distance from the centre of the Sun to its surface is about 696,000 kilometres. At sea, that is 2.3 seconds. The energy takes somewhere between several thousand and several 100,000 years. The sunlight warming your face today was released from the core sometime around when your species was learning to control fire. And nobody can tell you within 2 orders of magnitude when exactly. Therefore, if light is slow in glass and slower in water, and can be stopped entirely in a jar of sodium and takes geological time to crawl out of a star, in what sense is the invariant speed of the universe the speed of light? It is the speed light manages when nothing is in the way. Now go the other direction. What about things that are not light, that are not massless, and that show up early? On the 23rd of February, 1987, 3 detectors on 3 continents registered a burst of neutrinos within a window of about 13 seconds. Kamiokande 2 in Japan recorded 11 or 12 events. The Irvine, Michigan Brookhaven detector in Ohio recorded 8. And the Baxen Observatory in the Caucasus recorded 5. Roughly 24 particles in total from a supernova in the Large Magellanic Cloud, about 168,000 light-years away. The star was Sandelik, minus 69202. The light arrived about 3 hours later. Neutrinos have mass. We know this now with certainty, because they oscillate between types, which is only possible for massive particles, a discovery that earned Takaaki Kajita and Arthur McDonald the Nobel Prize in 2015. Massive means they cannot travel at sea, and yet they beat the light by 3 hours across 168,000 years of travel. The reason has nothing to do with speed. They left earlier. When a massive star's core collapses, the neutrinos are produced instantly and they stream straight out because they barely interact with matter at all. The light cannot leave until the shockwave from the collapse reaches the star's surface, which takes hours. The neutrinos got a head start, and their tiny mass slowed them by an amount far too small to eat into it. That is an ordinary answer, but it demonstrates something that is not ordinary at all. which is that the universe's causal speed limit is so consistent that a 3-hour arrival gap over 168,000 years is treated as a routine astrophysics problem rather than an anomaly. And when something did look like an anomaly, the reaction is worth examining closely, because it is the exact opposite of the story people tell about how physics handles inconvenient results. In September of 2011, the Opera collaboration announced that neutrinos fired from CERN in Geneva to the Gran Sasso laboratory in Italy, a baseline of about 730 kilometers, were arriving about 60 nanoseconds earlier than light would have. Faster than the invariant speed. If true, it breaks causality. The collaboration did not sit on it. They did not bury it. They published the measurement, said explicitly that they could not find an error and were inviting the community to find one, and were promptly torn apart for it by physicists who thought the announcement was premature. The error was found in February of 2012. Reporting in Science, Edwin Cartledge described the cause as a bad connection between a fibre optic cable running from the GPS receiver and an electronic card in a computer. Tightening the connector shifted the timing by roughly the amount in question. Matt Strassler's detailed account of the post-mortem identifies two separate faults working against each other. The loose fibre optic connector accounting for around 75 nanoseconds, and an oscillator clock running slightly fast accounting for around 37 nanoseconds in the opposite direction, with the residual producing the reported anomaly. A loose cable. 6 months of global excitement, several resignations from the collaboration leadership, and the answer was a connector that had not been screwed in properly. I bring this up because it is the cleanest available demonstration of how seriously the invariant speed is taken. Nobody in the field, at any point in those 6 months, seriously believed the result. Not because physicists are closed-minded, but because the causal structure of spacetime is load-bearing for everything. And if you break it, you do not get slightly faster neutrinos. You get a universe in which effects precede causes, and that is not a small revision. Which is the actual reason the speed limit exists, and it has nothing to do with speed. Take the spacetime interval again, the quantity every observer agrees on regardless of how fast they are moving. Time between two events, multiplied by c, squared, minus the distance between them, squared. Physicists working in relativity and cosmology and particle theory almost never write it that way. They write it with c set to 1. Not approximately 1. Exactly 1, by choice, as a matter of routine convention, in published papers and textbooks and lecture notes. When you first encounter that, it looks like laziness, a way of not having to carry a big number through the algebra. Laziness has nothing to do with it. The convention is a statement about what the constant actually is. Setting c to 1 means choosing to measure time and distance in the same units. If you measure distance in light seconds, then light travels 1 light second per second, and c equals 1, and it disappears from every equation it was in. The space-time interval becomes time squared minus distance squared. Energy equals mass. Momentum equals mass times velocity. The equations get simpler because a piece of clutter has been removed, and the piece of clutter was a unit conversion. The best articulation of this that I know of appears at the very start of Space-Time Physics, the textbook by Edwin Taylor and John Archibald Wheeler, in a section called The Parable of the Surveyors. It goes roughly like this. In a certain town, there are 2 guilds of surveyors. The daytime surveyors measure north and south using 1 unit, and east and west using another, because the northward direction is sacred and requires a sacred unit. The nighttime surveyors do the same thing, but with different conventions. Both guilds can map the town perfectly well, both produce internally consistent results, and both are baffled by a simple fact, which is that the distance between 2 landmarks comes out differently depending on which guild you ask. The resolution, obviously, is that they should be using the same unit for both directions. Once they do, the distance between 2 points becomes a single number that everyone agrees on, calculated by the ordinary Pythagorean rule, and the conversion factor between the sacred unit and the ordinary unit turns out to have no physical significance at all. It was an artifact of history and religion. Taylor and Wheeler's point is that we are the surveyors. We measure the 3 directions of space in meters, and we measure the 4th direction in seconds, for reasons that are entirely historical, having to do with the fact that human beings developed sundials and rulers independently, and did not know that the 2 things were dimensions of one object. And the number required to reconcile the 2 units, the number that lets you subtract a length from a duration, is key. It arose out of historical accident in humankind's choice of units, and it carries in itself no deeper physical significance than the number 1609.344, which is how many meters are in a mile. That comparison is the one to hold on to. If a civilization measured east to west distances in miles and north to south distances in meters, they would find a constant 1609.344 showing up in every geometrical calculation they performed. It would appear in their equations for the diagonal of a rectangle. It would look fundamental. It would look like a fact about the world. And a bright student would eventually ask what it is the speed of, and the answer would be that it is not a speed at all, it is a conversion, and the only reason it looks like a property of nature is that their ancestors used 2 different rulers. That is what C is. The exchange rate between 1 second and 300 million meters, forced on us by the fact that spacetime is one object and we insist on measuring it with 2 systems. And once you see it that way, the question of why nothing can go faster than light stops being a question about racing and becomes a question about geometry. Nothing can exceed C for the same reason nothing can be more north than north. There is no barrier there at all. There is only the shape of the thing, which raises the obvious follow-up, and it is the one that fringe physics has been chewing on for 30 years. If the number is a conversion factor rather than a law, could it change? Could it have been different in the early universe? Could it be drifting now? The answer that most physicists will give you, if you push them, is that the question as usually asked is not merely unanswered, but meaningless, and the reasoning behind that is one of the sharpest things in modern physics. Michael Duff laid it out in a paper posted in 2002, arguing that the time variation of dimensional constants such as the reduced Planck constant, the speed of light, the gravitational constant, the electron charge and the Boltzmann constant is a variation of quantities that are merely human constructs, whose number and values differ from one choice of units to the next, and that such variation has no operational meaning. He quotes Paul Dirac to the same effect, that talking about whether a thing is constant or not does not have any absolute meaning unless that quantity is dimensionless. Work through why. Suppose the speed of light halved overnight. Everywhere, uniformly, what would you measure? You would measure it with rulers and clocks, and the rulers are made of atoms whose size is set by the electromagnetic interaction, and the clocks tick at rates set by atomic transitions, and all of those depend on C as well. Everything you would use to detect the change is made out of the thing that changed. The measurement cancels. There is no experiment, even in principle, that distinguishes a universe where C halved from a universe where it did not, because a meter and a second are not independent of it. What you can meaningfully ask about are the dimensionless numbers, the pure ratios that have no units and therefore do not care what conventions you use. The most important of those is the fine structure constant, usually written as alpha, which governs the strength of the electromagnetic interaction. Its current value from the 2022 adjustment of the fundamental constants is 0.0072 9735-25643 with an uncertainty of about 1.6 parts in 10 billion. Its reciprocal is the famous number 137.0359991177. If that number were different, chemistry would be different. Stars would burn differently. If it changed over cosmic time, it would leave fingerprints in the light of distant quasars, because the wavelengths of atomic absorption lines depend on it. And in 1999, a group led by John Webb, using the Keck telescope in Hawaii to look at absorption lines in gas clouds sitting between us and distant quasars, reported in Physical Review Letters, volume 82, page 884, that the fine structure constant appeared to have been slightly smaller in the past. They followed it up in 2001, in volume 87, with a stronger result, a deviation of about 7 parts in a million with a statistical significance of around 4 sigma, across a redshift range covering most of the history of the universe. And in 2011, in volume 107, they went further and reported a spatial variation. A dipole, with alpha appearing larger in one direction on the sky and smaller in the other, at a claimed significance of 4.2 sigma. If that is real, it is one of the most important results in the history of physics, because it means a fundamental constant is not constant and the universe has a preferred direction. It is almost certainly not real. And I say that with regret rather than satisfaction. The Oklo Natural Nuclear Reactor in Gabon, a uranium deposit that spontaneously sustained fission reactions about 1.8 billion years ago, provides a completely independent constraint, and Thibault de Moore and Freeman Dyson analysed it in Nuclear Physics B, volume 480, in 1996, and found no variation at a level roughly 100 times tighter than the quasar claim. Independent quasar surveys using the Subaru telescope have not reproduced the Webb signal. The general assessment in the field is that the effect is most likely a wavelength calibration systematic in the spectrographs. The dipole is not established physics, but the fact that this is how the argument had to be conducted, entirely in terms of a dimensionless ratio rather than in terms of the speed itself, is the point I want you to take from it. Even the physicists who have built entire cosmologies out of a varying speed of light have to do it this way. João Maguejo and Andreas Albrecht published a proposal in Physical Review D, volume 59, in 1999, suggesting that light travelled much faster in the very early universe, and that this could solve the same problems that inflation was invented to solve, without inflation. It is a minority position, and the community's reception has been sceptical, but it has one virtue that a great many alternative cosmologies lack, which is that it makes a falsifiable prediction. In 2016, Nyayesh Afshordi and Maguejo published in the same journal, volume 94, a specific predicted value for the spectral index of primordial density fluctuations, 0.96478, with no primordial gravitational waves. The value measured by the Planck satellite sits at about 0.965, which is uncomfortably close, and the gravitational wave prediction remains untested. I do not know what to do with that. It may be coincidence. It probably is. But the theory that says the speed of light was different in the past has produced a sharper testable number than most of the theories that say it was not, and that is the kind of thing that should be discussed more than it is. Which brings us back to what the limit is actually protecting. Sean Carroll has made the point in public talks that the speed of light should really be called the speed of causality, and that phrase is doing a lot of work. Because the reason the universe cannot tolerate faster than light signalling has nothing to do with energy requirements or engineering difficulty. It has to do with the fact that if you could send a signal faster than C, you could send a message into your own past, and this is not hand-waving. It is a direct consequence of the relativity of simultaneity that you can work out on paper in about 20 minutes. The argument was formalised in 1970 by Gregory Benford, David Book and William Newcomb in a paper in Physical Review D. Volume 2, pages 263 to 265, with the wonderful title The Tachyonic Antitelephone. Benford, incidentally, is both a working astrophysicist and a well-known science fiction novelist, which is a combination that shows in the writing. The setup is this. 2 observers moving relative to each other, each equipped with a device that sends signals faster than light. Because they are moving relative to each other, they disagree about the order of events that are separated in space, and that disagreement is not an illusion or a measurement error. It is a real feature of how their reference frames slice up space-time. Observer A sends a superluminal signal to observer B. In A's frame, the signal arrives after it was sent, but in B's frame, moving relative to A, that same signal travelled backwards in time. B then replies, using the same device, and in A's frame that reply arrives before A sent the original message. You have built a telephone to yesterday, and the paper's abstract states the conclusion flatly, that experiments then underway or contemplated involving superluminal signalling must either yield negative results or give rise to causal contradictions. The universe declined to be a paradox. All such experiments have yielded negative results. But there are things that exceed C, and this is where a great deal of popular confusion lives. So let me be precise about what is actually going on in each case, because the exceptions are not exceptions. The most striking of them was published in Nature on the 20th of July 2000 by Leyden Jar, Alexander Kuzmish, and Arthur Dogariou at the NEX Research Institute in Princeton. They sent a laser pulse through a chamber of cesium vapor prepared with a specific gain profile and measured a group velocity index of -310, plus or minus 5. A negative index. What that means physically is that the peak of the outgoing pulse left the far side of the chamber before the peak of the incoming pulse had entered the near side. The pulse appeared to exit before it entered. That is a real, replicated, published measurement, and it does not violate causality at all. The reason is that the peak of a pulse is not the pulse. A light pulse is built from a spread of frequencies, and the leading edge of it, the faint front that arrives before the bulk of the energy, already contains all the information needed to reconstruct the shape. What the cesium does is reshape the pulse, amplifying the front and attenuating the back, so the reconstructed peak sits earlier. No information travelled faster than C. Nothing arrived that was not already on its way. The front edge, which is the only thing that matters for signalling, never exceeds the limit. The expansion of the universe is a cleaner case. Galaxies beyond the Hubble radius recede from us faster than C, and this is entirely permitted. Because they are not moving through space, the space between us is growing. Relativity restricts motion through spacetime. It has nothing to say about how much spacetime there is. There are trivial cases too. Sweep a laser pointer across the face of the moon, and the spot moves across the surface faster than C. Nothing is travelling. The spot is not an object, it is a sequence of separate events, each caused by a different photon that took the ordinary amount of time to get there. The blades of a very long pair of scissors have the same property. And then there is entanglement, which is where the confusion tends to become permanent. When two particles are prepared in an entangled state and separated by an arbitrary distance, measuring one immediately determines the outcome you will get on the other, with no delay of any kind. That correlation is real. It has been verified to an absurd degree of confidence. And the 2022 Nobel Prize in Physics went to Alain Aspect, John Clauser and Anton Zeilinger for the experiments that closed the loopholes. But you cannot use it to send anything. This is not a practical limitation, it is a theorem, called the no communication theorem. and it says that no measurement performed on one half of an entangled pair can change the statistics observed on the other half. The person at the far end sees random noise, and it only becomes correlated when you compare notes, and comparing notes requires an ordinary signal travelling at or below C. Entanglement produces correlation without communication, and the distinction is the entire point. The exceptions all collapse into the same statement. Nothing that could carry a cause has ever been observed to travel faster than the invariant speed, in any experiment ever, and the structure of spacetime does not appear to permit it, even in principle. Which is the answer to what the number is the speed of. It is the speed of cause and effect. It is the rate at which anything, anywhere, is permitted to influence anything else, and it does not care what the influence is made of, whether it is light or gravity, or the strong nuclear force, or the motion of a body, or a decision you make. And that is where it stops being an abstraction, and starts being about you. The invariant speed is not fast. It is one of the great misconceptions of popular science that it is fast, and it comes from the fact that everything we compare it to is on our own scale. Grace Hopper, who was a rear admiral in the United States Navy and one of the people who invented modern computing, used to hand out pieces of wire at lectures. Each piece was 11.8 inches long, about 30 centimeters, and she called them nanoseconds. That is the distance light travels in 1/billionth of a second, and it is the absolute maximum distance a signal can cross inside a computer in that time. She started giving them out in the late 1960s. According to the Smithsonian's National Museum of American History, to make engineers understand that if they wanted faster machines, they would have to build smaller ones, because the wire was not going to get any shorter for free. She paired it with a coil of wire 984 feet long for a microsecond, and later with grains of pepper for a picosecond. And she pointed out, in a lecture at Lincoln Laboratory in 1985, that the wire was the optimistic version, because signals in copper are slower than light in vacuum. Your processor runs at a few billion cycles per second, which means that in the time it takes to complete one cycle, light crosses a few centimeters. The speed limit of the universe is a design constraint on the object in your pocket. Every chip architect on Earth spends part of their working life negotiating with it. Go up a scale. Fibre optic cable running under the Atlantic carries light through glass, which means it runs at roughly 2/3 of C, about 200,000 kilometers per second. The Great Circle distance from New York to London is around 5,500 kilometers. That gives a one-way floor of about 27 milliseconds and a round-trip floor of around 55. In 2015, a cable called Hibernia Express was completed for something in the region of $300 million, laid along a shorter route than the existing cables, and it delivers a round trip of just under 59 milliseconds. Financial firms paid enormous sums for access to it, because in high frequency trading the difference between 59 milliseconds and 65 milliseconds is the difference between taking a price and missing it. There is an oft-cited figure in the industry that a single millisecond of latency advantage is worth somewhere north of $60 million. That is human beings spending hundreds of millions of dollars to buy back fractions of a thousandth of a second from the geometry of spacetime. And the geometry does not negotiate. You can lay a straighter cable. You cannot lay a faster one. Go up again, and the constraint stops being expensive and starts being lonely. The light from the sun takes 8 minutes and 20 seconds to reach you. If the sun went out right now, you would have 8 minutes and 20 seconds of ordinary afternoon before you found out. Signals to Mars take between about 4 and 24 minutes each way, depending on where the two planets are in their orbits, which is why every rover that has ever landed there has had to land itself. There is no joystick. By the time the telemetry showing the start of the descent reaches Earth, the rover has been on the surface, or in pieces on the surface, for several minutes already. Proxima Centauri, the nearest star to the Sun, is 4.24 light-years away, which means the fastest possible reply to any message we send is 8.5 years. The centre of our own galaxy is about 26,000 light-years away. The light arriving from it now left when the last glacial maximum was underway and human beings were painting animals on cave walls in southern France. And then there is the object that makes it visceral. Voyager 1 launched in September of 1977. It has been travelling outward for nearly half a century at about 17 kilometers per second, which is fast enough to cross the continental United States in about 4 minutes. As of late 2025, it was somewhere around 25 billion kilometers from Earth, more than 166 times the distance from the Earth to the Sun, and the one-way light time to it was about 23.5 hours. NASA has projected that Voyager 1 will reach a distance of exactly 1 light day, 25,902,000,000 kilometers, in November of 2026. 49 years of continuous travel at 17 kilometers per second to reach the distance light covers between one breakfast and the next. I find that number harder to sit with than any of the cosmological ones. The most distant object humanity has ever made, after half a century of unbroken flight, is 1 day away at the speed of causality. The invariant speed is not a fast speed, it is a slow speed applied to a very large room, and the consequence is that the universe is broken into regions that cannot reach each other in any useful time. That is the reason we are alone in any practical sense, regardless of what else is out there. The limit does not sit on our engineering. It sits underneath it, in the floor, and it gets worse when you add the expansion. Space is not merely large, it is growing, and the growth is accelerating, which has been the consensus position since the supernova surveys of 1998. Put those two facts together, a finite causal speed and a universe whose distances are stretching faster all the time, and you get a consequence that I think is the single most undercommunicated result in cosmology. There is a distance beyond which a signal you send today will never arrive. Ever. Not in 1 trillion years. The space between here and there is expanding faster than the message can cross it, and the gap is widening faster than the message is closing it, and the message will simply travel outward forever, falling further behind, never landing. That boundary is called the cosmological event horizon, and it is not the same thing as the edge of the observable universe. The observable universe is what we can see, meaning what has had time to reach us. The event horizon is what we can reach. The second one is very much smaller than the first. The estimates for how much smaller depend on the cosmological model and on the parameters you feed it, and I want to be careful about handing you a precise number for something this model dependent. But the commonly quoted figure in terms of moving volume is that we could ever send a signal to only a few % of the galaxies we can currently see. The overwhelming majority of the objects visible in a deep field image are already permanently causally severed from us. We can watch them, we can never touch them, or greet them, or receive an answer from them, and neither can any descendant of ours, however long the species lasts and whatever it builds. And the number is falling. Galaxies cross that horizon continuously. At some moment in the past, for every galaxy currently beyond it, there was a last instant at which a signal sent from Earth could have arrived, and that instant passed without anyone noticing, and it will never come back. That is the invariant speed, doing its work, not as an abstraction in a textbook, as a permanent partition of everything that exists into the part you could in principle affect and the part you could not, drawn by a conversion factor between seconds and meters, enforced without exception, and shrinking. But the loneliness is not the disturbing part. The disturbing part is what the same limit does to the word now. Here is the mechanism, and it is one line. Take two observers moving relative to each other at speed v. Take two events separated by a distance d along the direction of that motion. The two observers will disagree about whether those events happened at the same time, and the size of their disagreement is v times d. Divided by c squared. Look at the structure of that expression. The disagreement grows with the speed, which you would expect, but it also grows with the distance, without limit, and it is divided by c squared, which is a very large number, roughly 9 times 10 to the 16 in the usual units. Which means the effect is negligible for ordinary speeds over ordinary distances, and this is why you have never noticed it. But the distance term has no ceiling. Make d large enough and any speed at all, however small, produces an arbitrarily large disagreement about what is happening now. Roger Penrose put a specific number on this in The Emperor's New Mind, published in 1989, and the example has been called the Andromeda paradox ever since. Two people pass each other on a street. They are walking at ordinary walking pace in opposite directions. Call it 1 metre per second, which is a stroll. At the instant they pass, they are at the same place, and their watches read the same time, and they are looking at the same street. The Andromeda galaxy is about 2.5 million light-years away, which is around 2.3 7 times 10 to the 22 meters. Run the numbers. 1 meter per second times 2.3 7 times 10 to the 22 meters divided by 9 times 10 to the 16. The answer is about 260,000 seconds, which is about 3 days. Those two pedestrians, at the moment they pass each other, have definitions of the present moment in the Andromeda galaxy that differ by 3 days. Penrose dressed it up with an invading alien fleet for effect. For the person walking one way, the fleet has already launched. For the person walking the other way, the decision to launch has not yet been made. Both of them are correct. Neither of them is in a privileged frame. There is no fact of the matter in the physics about which of their nows is the real one. And notice that they did nothing exotic. They walked. If you increase the pace by about a foot per second, you shift the Andromeda present by roughly another day. I want to be careful about a common overstatement here because it circulates and it is wrong. This does not mean either pedestrian can see or influence what is happening in Andromeda. Both of those events are space-like separated from both pedestrians, meaning no signal could pass between them either way. Neither person can find out. Neither person can act on it. The disagreement is entirely about the labelling of simultaneity, not about access. But that defense, which is the standard one and which is correct as far as it goes, does not actually dissolve the problem. It sharpens it. Because the question is not whether you can see it. The question is whether it is there. If you hold the ordinary intuitive view of time, the one everybody operates on, then the present moment is special. The past is gone. The future does not exist yet. Reality consists of a thin slice of now, moving forward, and things become real as it reaches them. That view is called presentism, and it is what your entire nervous system asserts every waking second. Relativity says there is no such slice. Or rather, it says there are infinitely many, one for every possible state of motion, all equally valid, all disagreeing with each other. And no procedure anywhere in physics for picking out the correct one. The slice does not belong to the universe. You bring it with you, and its angle depends on how fast you are walking. And if there is no privileged slice, then the question of which events are real cannot be answered by asking which events are happening now, because now is not a global fact. That is the argument. And it was made formally in the philosophical literature, and the conclusion it reaches is the thing I flagged in the Cologne lecture and have been walking toward since the first 5 minutes. In 1966, a Dutch physicist named Cornelis Willem Reitdijk published a paper arguing that special relativity entails determinism. A year later, in 1967, the American philosopher Hilary Putnam published a paper in the Journal of Philosophy, volume 64, pages 240 to 247, called Time and Physical Geometry, making a closely related argument with more rigor. Together they are known as the Reitdijk-Putnam argument, and it is one of the very few places where a result in physics has been converted into a metaphysical claim that most working physicists quietly accept and almost never state. The argument runs in 3 steps, and each one is uncontroversial on its own. Step 1. If 2 events are simultaneous for an observer, and that observer is in a perfectly ordinary inertial state of motion, then those events are equally real. Whatever reality means, it does not distinguish between 2 things that are happening at the same time in the same frame. This is not a physics claim, it is a reasonableness claim, and it is very hard to reject. Step 2. Reality is transitive. If event A is real relative to me, and event B is real relative to A, then B is real. If you deny this, you are committing to a version of reality that is relative to observers in a way that almost nobody finds acceptable, because it means whether something exists depends on how fast you are walking. Step 3. Relativity of simultaneity, which we have just established with the pedestrians. There exist observers, in perfectly ordinary states of motion, whose plane of simultaneity includes events that are, from your perspective, in the future. Put the 3 together. Some events in your future are simultaneous with events that are simultaneous with your now. By transitivity, they are real, not going to be real. Real, in the same sense in which your breakfast this morning is real, which means the future exists, not as a possibility, not as a probability distribution, not as something waiting to be determined, as part of the structure, in the way that the far side of a mountain exists while you are standing on this side of it. This is the block universe, and it is the direct consequence of the invariant speed, not of light, of the conversion factor between space and time, which is the thing that makes simultaneity relative in the first place. If C were infinite, if there were no conversion factor because time and space were genuinely separate things, simultaneity would be universal, everybody would agree on now, and presentism would be perfectly comfortable. It is the finiteness of the invariant speed that shreds the concept of a universal present. The number that a committee fixed by decree in 1983 is the reason there is no such thing as now. Hermann Weyl, one of the great mathematicians of the 20th century and a colleague of Einstein's at Princeton, put it about as plainly as it can be put in his book Philosophy of Mathematics and Natural Science, published in English by Princeton in 1949. He wrote that the objective world simply is. It does not happen. Only to the gaze of my consciousness, crawling upward along the lifeline of my body, does a section of this world come to life as a fleeting image in space which continuously changes in time. Sit with the verb. Crawling, Weyl is describing you, as a static 4-dimensional object embedded in a fixed geometry, and the only thing that moves is the region of it that is currently lit up by awareness. And then there is the letter. Michel Besso was Einstein's oldest friend. They met in Zurich in the 1890s, when Einstein was a student, at a musical evening. Besso got him the job at the patent office in Bern. He is the only person thanked in the 1905 Relativity paper, where Einstein writes that he is indebted to his friend and colleague M. Besso for several valuable suggestions. They argued about physics by letter for more than 50 years. Besso was, by Einstein's own account, the the best sounding board in Europe. Besso died on the 15th of March, 1955. On the 21st of March, Einstein wrote to the Besso family. The letter is in the Einstein archives, and the relevant passage reads that Besso has departed from this strange world a little ahead of him, and that this means nothing, because for those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. Einstein died on the 18th of April, 1955. 28 days later. I have gone back and forth on how to present that letter, and I want to be honest about the difficulty. It is a condolence letter. It is not a physics paper. Einstein was 76. He had just lost the friend he had been arguing with since he was a student, and he was writing to console a grieving family, and he reached for the thing he actually believed about time in order to do it. Whether he intended it as a technical claim or as comfort, or whether for him those two things were not separable, I do not know, and nobody does. But he did not invent the sentiment for the occasion. It is the same picture Minkowski laid out in Cologne in 1908, 4 months before his appendix killed him. It is the same picture Weyl described in 1949. It is the same picture that Reitdijk and Putnam derived formally a decade after Einstein was dead, and it is what the mathematics of relativity says if you read it without importing your own experience of duration into it. Now, the honest counterweight, because I am not going to hand you a philosophical position dressed as an experimental result. The block universe is an interpretation. It is not a measurement. Nobody has observed the future existing, and nobody could, because the argument itself guarantees that the events in question are causally inaccessible. There are serious people who reject it. Tim Maudlin, a philosopher of physics at New York University, has argued at length that relativity does not force the block picture, that the argument from simultaneity to reality involves philosophical assumptions about existence that are doing more work than the physics is, and that one can perfectly well hold that the passage of time is a fundamental feature of the world, and that the relativity of simultaneity is a fact about coordinates rather than about being. Lee Smolin at the Perimeter Institute went further in his 2013 book Time Reborn, arguing that time is the one thing in physics that is genuinely real, and that the block picture is an artifact of mistaking our mathematical representations for the world. There are also intermediate positions, most notably the growing block, in which the past and present are real and the future genuinely is not, and reality accretes. Those positions are defensible, and the people holding them are not cranks. This is a live argument, and it is not going to be settled by an experiment, because every position in it predicts identical observations. But there is something that I think does not get said clearly enough, and it is the point at which the disagreement stops being reassuring. Every one of those interpretations, including the ones that want to save the flow of time, agrees on the physics. They agree that the equations of relativity contain no privileged present. They agree that simultaneity is frame-dependent. They agree that the fundamental laws, all of them, from Newton's through Maxwell's through Einstein's through the Schrödinger equation and quantum field theory, are time-symmetric, meaning they work identically forwards and backwards and contain nothing whatsoever that distinguishes a direction. They agree that there is no term anywhere in fundamental physics corresponding to the passage of time. The disagreement is entirely about whether something real is missing from the equations, or whether nothing is missing and your experience is the illusion. Which means that the one thing everybody in the argument concedes, presentist and eternalist alike, is that the flow of time is not in the physics. That is not the contested part. That is the shared premise from which the argument starts. There is a way of stating this that gets used a lot in popular accounts, and I want to give it to you with its problems attached rather than let you meet it somewhere else without them. The claim is that everything in the universe moves through space-time at exactly c, always without exception. An object you would describe as perfectly stationary is moving through time at the full rate. Start it moving through space, and some of that motion gets diverted out of the time direction into the space direction, which is why moving clocks run slow, and if you could get all the way to c, all of your motion would be through space and none through time. Brian Greene put a version of this in The Elegant Universe, and it has been repeated widely ever since, because it is the most intuitive picture anybody has produced for what time dilation actually is. The technically defensible core of it is that the magnitude of an object's forward velocity, its velocity through four-dimensional spacetime, is always exactly c. That is true. It is also, and this is the criticism, close to a tautology, because the forward velocity is defined by differentiating position with respect to proper time, and proper time is defined in a way that makes the magnitude come out to c automatically. It is a normalization convention. It is not a speedometer reading. Worse, massless particles do not have a forward velocity of this kind at all, because you cannot differentiate with respect to a proper time that does not tick, which means the tidy picture of light using up all its motion on space breaks down precisely at the case it was invented to explain. The related claim that photons experience no time has the same shape of problem. A photon has no valid rest frame. You cannot ride along with one, not because it would be difficult, but because the transformation is undefined, and asking what light experiences is not a question relativity will answer. What is true is that the space-time interval along a light path is exactly zero. From emission to absorption, across billions of light years, the interval is zero. Whether that means anything experiential is not a physics question, and I am not going to pretend it is. I use the picture anyway, with those caveats, because the caveats do not damage the thing that matters. Which is that your motion through time and your motion through space are not separate quantities, they are components of one thing. And the exchange rate between them is the number that got voted into the definition of the metre in 1983. Which means the constant does not sit out there in space, waiting to be measured. It runs through you. The signals moving down the axons in your brain right now travel at somewhere between 1 and 100 meters per second, which is a rounding error against c, but the limit still applies to them, and it applies to the electrochemistry inside every cell in your body, and to the electromagnetic binding holding your molecules together. Every atom in you is held in place by forces that propagate at the invariant speed. The distance between one side of your head and the other is about 15 centimeters, which light crosses in half a nanosecond. Your brain has no mechanism for registering anything that fast. Which means that what you experience as a single unified present moment, the sense that everything you are perceiving is happening simultaneously, is assembled by a nervous system that runs about 100 million times slower than the causal structure it is embedded in. Your now is a construction. It has a duration of a few hundred milliseconds, it is stitched together from signals that arrived at different times, and it is calibrated to a body about 2 meters tall. The universe has no equivalent. There is no process anywhere in physics that corresponds to what you are doing when you experience this sentence as happening now. I have been building toward this since the beginning, and I want to state it without decoration. The speed of light is a conversion factor between the units we use for space and the units we use for time. It is in the equations because we chose 2 rulers instead of 1. Light travels at it because light has no mass, and gravitational waves travel at it because they have no mass either, and neither of them owns it. It falls out of the symmetry of space-time in a derivation published in 1910 by a lens designer who was shot or starved in Leningrad in 1942. It has been fixed by definition since 1983, which means the most fundamental constant in physics is now, formally, a unit of measurement rather than a discovery. And because it is finite, there is no universal present. And because there is no universal present, the events you call the future are not distinguishable in any equation anybody has ever written down from the events you call the past. Ole Rømer looked at a moon that would not keep time and worked out that, when you look at anything, you are looking at the past. He was right about more than he knew. Every photon arriving at your retina right now left its source in your past. The screen in front of you, a nanosecond or two. The room, less. Your own hand, if you hold it up, about 3 billionths of a second. There is no version of perception that is contemporaneous with its object. You have never once, in your entire life, seen the present. What you have been calling the present is a reconstruction, assembled from stale information, by a system that is itself a pattern in the same geometry it is trying to describe. Michelson spent 50 years chasing a number that turned out to be a choice of units, and died mid-measurement in a sealed tube on a ranch in California. Foucault proved Newton wrong in an afternoon, and lost his hands to a disease nobody could name. Minkowski said the true thing once, in Cologne, in September of 1908, that space by itself and time by itself are doomed to fade into shadows, and was dead of a burst appendix before the next winter ended. Ignatowsky showed that light was never needed and vanished into a siege. Einstein wrote to a dead friend's family that the division between past, present and future is a stubbornly persistent illusion, and was dead himself in 28 days. None of them were describing something that happened. They were describing something that is. The block does not move. It does not need to. Every measurement any of those men ever took is still there, at its own coordinates. Exactly as real as this sentence. Michelson is still at the eyepiece in 1887, rotating the interferometer on its mercury bath, finding nothing. Over and over, permanently, Minkowski is still standing up in Cologne. The room in Sèvres is still voting. And the reason all of that is still there, the reason the past is not gone, and the future is not pending, is a number that got its name from a Latin word it was never derived from, attached to a phenomenon it does not belong to, describing a property of the only thing you have ever been made of. You are not travelling through time. Nothing is. There is no motion in the block, and there never was, and the sensation you are having right now of this moment arriving and passing is the only place in the universe where anything is happening at all. The equations do not know which way time runs. You are the part that had to feel it.